Welcome to Cloud Native Live. I'm so glad you're here. Here we dive into the code behind Cloud Native. I'm your host today. I'm Whitney Lee, and I'm a CNCF ambassador and a developer advocate at VMware. Every week, we bring new presenters to showcase how to work with cloud native technologies. We'll build things, we'll break things, and we'll answer your questions. Today, we're going to save all the questions to the end and have a discussion after the presentation. Here with us now, we have Jason Andrews. He's here to teach us about how to get more with multi-arch clouds. So this is an official live stream of the CNCF, and as such, it's subject to the CNCF Code of Conduct. So please don't add anything to the chat that would be in violation of that Code of Conduct. So basically, just be nice to each other, be nice to the presenter, be nice to me. You got this. We can do it. So friends who are joining us live, please say hello in the chats and say where you're from. I love how we're a global community. I just think it's the coolest thing ever. So if you have any questions, please post them to the chat and we'll get to them at the end. And then with that, I'll hand it over to Jason Andrews to kick off today's presentation. Jason, tell us about yourself, please.
Yeah, I'm Jason Andrews. I work at ARM, so I work in a developer system organization, and we do lots of activities to help software developers work on the ARM architecture.
Awesome. That's super cool. Thank you so much for sharing your time and your expertise with us today.
Yeah, no problem. Glad to be here. Thanks, everyone, for joining.
Cool. Are you ready for me to share your screen?
Yes, let's go ahead and we can get started.
Excellent.
Okay. All right, everybody. So I'm just going to start off today with a couple quick slides just to give you a little bit of orientation of where things are and what we're going to talk about. And then we're going to spend the majority of our time with some hands-on activities around multi-architecture infrastructure, primarily with Kubernetes today. That's what we're going to talk about. So as I mentioned, I'm coming from ARM in our developer ecosystem group. And one of the reasons we're here to talk to you today about multi-architecture is that the ARM architecture is ramping up and gaining a lot of traction in different areas of cloud computing. So you can see different cloud service providers have been adding ARM instances and virtual machines and a lot of managed services, which all run on ARM. So as a developer, you might want to take advantage of those. So yeah, I guess first point is ARM is growing. The architecture is spreading in many different kind of places. And then you might ask yourself, well, why? I mean, what's the benefit for me? So as a developer, there's probably three main things that you want to think about here. One is performance. Second one is going to be reduced cost. And the third one is sustainability. So lots of projects are looking into the ARM architecture as a way to really benefit from better price performance, as well as build sustainability in the resources that they're using. So that's really, I would say, the main reason why people look into the ARM architecture. Price performance is a big one. It's always better to run fast and cost less. So that might be a reason why you look into the architecture. So the good news about the ARM architecture is lots of things already work. So lots of software already works. In fact, I would say most software already works. But as a developer, if you've been working in a single architecture for a long time, this might be a little bit new to you, and how to migrate and how to think about having multiple architectures in your environment. So that's what we're going to talk about today. So I'd really encourage you, if you haven't spent a lot of time with the ARM architecture or any time, the best way to get started is to just get a machine, right? There's lots of ways you can get a virtual machine, whether that be on your laptop or in the cloud. There's different places you can do that. And then I would just ask you to, just kind of experiment with your projects, your dependencies, what kind of things work. Maybe you find something that doesn't. And just kind of dig in. I mean, for most people, that's the best way to get started. Is just set up a VM, dig in there, and figure out what's the same and what's different about running on the ARM architecture. In terms of what some other things you need to think about, so maybe some dependencies. Yeah, take a quick scan, look over your libraries, frameworks, runtimes, different things that you use in your projects, and see if they're supported on ARM. In most cases, most software is already working. I mean, all the Linux distributions, a lot of the tools you use probably are already there. It's not a big deal. But typically what I encourage people to do is just kind of make a little bit of a checklist or investigate some of your issues. You might see a container that doesn't work on ARM. Okay, I'll just put a note, make a note of that, and keep that in my pocket as I continue forward in my journey. The other thing to point out is newer is better. That's not always the case in software development, but because the ARM architecture is newer in server and cloud, you probably want to use the latest, newer software if possible. That will typically help you. A couple other tips before we get into the hands-on part. If you're running things that are interpreted languages, it's usually very straightforward. Everything is typically the same. If you're doing things like Java, you might find that the performance improves significantly on newer versions. So I'd encourage you to try newer versions if possible. Another little bit of a pitfall is sometimes you'll find shared objects in jar files that are kind of architecture specific. They're compiled images, compiled objects. You got to work with those because they won't run on the wrong architecture. Containers, tons of containers are already multi-architecture. Not always, but a lot of the things are. And then on the right side, the compiled applications. You're going to look for things that are not real portable in C and C++, could be intrinsics, things like that. Some other languages like Go works great. And again, newer versions are better. So starting from 1.18 and newer, that's going to give great performance. If you have older ones, then that might work, but the performance isn't going to be as good. So yeah, take a look at what you have, work through your dependencies, keep a checklist of that. And that's a good way to get started on ARM. So in terms of some scenarios, I mean, when developers want to try out ARM and check into the price performance benefits, typically they'll run into a variety of different things. So I just made a little table here with some kind of things that you might come up against. I mean, they're fairly specific, but it gives you a flavor for what you might face. So if you're doing something like Node.js application, you might find, hey, just works. I moved it over. I can't tell anything different about the architecture and its underlying instructions. Works great. If you're in C++ applications, you might come across intrinsics, which are architecture specific. Typically, these are SIMD type instructions, and there are tools and libraries that help you to migrate those over. So SSE to Neon and SIMD Everywhere are examples of tools you can use that are very minimal in terms of your source code changes and allow you to run those existing intrinsics in your code. You might find some dependencies that don't work on the ARM architecture. So you might find something in Python or a Python package that's not available. So, again, try to either you have to work around it, or best way is to ask the maintainers if they can add ARM support. I mentioned some performance things. So yeah, newer tools are better. Sometimes the crypto extensions of the ARM architecture haven't been implemented in the best performance way on older versions of tools. So take a look at that. Containers, again, if you find containers that don't support multi-architecture, ask the maintainers if they can do that. Couple other architecture specific things. So large system extensions is a feature of the ARM architecture that will normally just work and everything is fine. But if you had, say, an older C++ compiler, you might have some issues with that. Anyway, so you kind of get the flavor that, most stuff is there. You might hit some hiccups here and there, but definitely reach out if you need help. And I think you'll have a pretty smooth time. So what we're going to do today is get into the hands-on, and we're going to have a little bit of multi-architecture discussion running in Kubernetes. So we have an application that we're going to build. We're going to build container for that. It's a Go application. We're going to put it into container repository. And then we'll work with AWS EKS, and we'll have a mixed node cluster where we have a couple nodes which are AMD 64, and we'll have a couple nodes which are ARM 64. And I'll give you a little flavor of how containers map onto those nodes, and we can start up different kind of deployments and see how that works. So that's what we'll go over next. Okay, let me jump out of the PowerPoint here and we will get started. So essentially what I'm going to do is first, let's just go over the application itself a little bit. So it's super simple. I mean, it's just a Go application that is going to respond. And I probably won't even use the browser. I'll just do a curl and hit the application. and then you'll see it says it prints a hello message. And it'll print the node that it's on and the pod and the platform. So really, this is the key thing. This is the architecture value. So, if this application and its container lands on an AMD 64 node, that's what will be printed. And if it's running on an ARM64 node, then you'll see that is printed as well. So that's the basic application we're going to go through. Now, if you're not familiar with multi-architecture containers, this is kind of a prerequisite, I would say, to get into Kubernetes. So you probably want to learn that a little bit. Now, what I've done here with the simple Go application is I have a single Docker file which can actually build a few different ways. And I would encourage you to look into multi-architecture containers. But essentially what we're doing here is we're passing arguments for the target architecture, and then also here for the runtime container, which is going to be Alpine in this case. So it's copying in the Go, and then it's using this variable to compile the application for a specific architecture. Now, whatever machine you're on when you do this, if you don't specify the Go Arch variable, it's going to be whatever the native architecture is of the machine. Now, things are getting a little more complicated as people start picking up Apple Silicon because you will be picking up ARM64 as that native thing. So it depends which way you go. And if you just say from Golang, that's going to be the native architecture of your machine. Now, the runtime container, which is the second one down here, the second stage, that's the one that needs to run on the architecture we're going to schedule it on. Okay, so that's why you see there's a variable there, which is going to place whether that's AMD 64 or ARM 64. Now, in terms of building the container, there's a couple different ways to do it. If you just use Docker build, I have an example here of a script which is just Docker build, and then I tag the containers with either :ARM64 or :AMD 64, and then I can push those to Docker Hub or whatever container repository you want to use. So this is probably, if you have a traditional container, you haven't thought about multi-architecture before, you just build it on an AMD 64 machine, that's what you get, right? You get an AMD 64 container, it can only run on AMD 64 nodes. So let's just say, for example, if I can build this application both ways, I'll do a Docker build, just straight build, and I'll pass in the architecture in each case, and then I'll pass in that runtime container for Alpine, has a slightly different prefix on ARM, and then I'll get two containers there. So what it ends up when I do that, I have here in my Docker Hub account, you'll see I have two different containers. One has the ARM64 tag, and one has the AMD 64 tag, and I built those independently, just showing you how I did it. Okay, so that's like a way that you can just build containers that are architecture specific. Right? That's kind of the historical way. Now, the new way to do this is by way of BuildX. So BuildX is a ability that Docker has to build with a single instance. You just call Docker BuildX, and then you specify the platforms that you want to support, in this case, AMD 64 and ARM 64, and then it will build that as a multi-architecture container. So if I jump back here on Docker Hub, this is the one I have go-archx. Okay, so the tag, I just put a 1.0 as the tag, but if I open it, you'll see there's two drop downs here. There's an AMD 64.
Will you zoom in on that, please? Sorry to interrupt.
Yes.
Will you zoom in?
Yeah,
Thank
no
you.
problem.
Yeah, great, thanks.
Okay. Yeah, great. So so this one is a multi-architecture container. So if I do the drop down on the OS architecture there, you'll see there's two entries. One is AMD 64 and one is ARM 64. Now, the beauty of the multi-architecture container is that whatever machine you're on, when you go to run the container runtime will go to find it, and it'll say, oh, I'm on a ARM64 machine. I see that this image supports ARM64, and it'll go get the right image and then just automatically run it on that machine. Okay, so this is a way just to keep everything simple, support two architectures in a single image. Okay, now there's one more variable that I'm going to show here. which is a Docker manifest command. I believe this is still in experimental in Docker, but it's been there a while, so I'm not totally sure. But what Docker manifest does is it takes your individual images that I described at first for each architecture, and then it kind of like merges those together into a multi-architecture image. So if I, went on an ARM machine and I built the ARM image, stuck it on Docker Hub, then I went on AMD 64 machine, built that image, stuck it on Docker Hub, then I can merge them together, and then I end up in the exact same place that I would as if I use BuildX. And this is handy because in a lot of cases, you don't want to go through a lot of the hoops related to BuildX. You'd rather just, use two separate machines, build for each architecture, and kind of link them up at the end using this manifest command. So, all that gives you a little bit of background on multi-architecture images, what you're going to need if you go into a mixed node Kubernetes cluster that we're going to do next. So hopefully that's clear. I have some examples how that works. So I'm not going to run the commands for the Docker builds right off. I just showed you they are on Docker Hub now. And then let's get into the Kubernetes part and see how this works in terms of running the application in our cluster. So in terms of the cluster that we have, I mentioned it's going to be EKS. So what I found is super easy to create a cluster with EKS CTL. So that's what I used here. With two different node groups. So there's one node group, which is the AMD 64 architecture with 2 nodes. And then there's one, which is a C6G. That's the Graviton processor. And so that's going to be with the ARM 64 architecture. So we're going to have 2 nodes of that in each one. And then I ran this with EKS CTL with this YAML file, and that sets up the cluster. Okay. So what we can do is, let me just run get nodes there, and then you'll see here's my cluster. I have 4 nodes running. Okay, so now what we want to do is think about, maybe some mixed node scenarios. So let's just go with the AMD 64. So I have a YAML file here, which is going to be specifically only AMD 64. Okay, so it's has a container, which is the one I just showed you on Docker Hub, and it has that AMD 64 at the end. So this image is only going to run on AMD 64. I guess the other interesting point is the node selector down here. So by matching this node selector to AMD 64, when I run this, apply this YAML file, it's going to get that container, and it's going to run it on one of the 2 AMD 64 nodes here. So let's just do apply -f and then the AMD. And so this will create the deployment. And let's do a get pods. And then you'll see now I'm running one AMD 64 deployment. And I believe I have a one replica right here. So that's running on that, that node. Now I have a little bit of a script here, or I can just do a curl probably and hit that endpoint. So I think I showed on the first picture, there's a load balancer in front of these nodes. I can hit that, and then you'll see it prints the CPU platform is Linux AMD 64. So that's the only thing currently running in my cluster. So every time I do a curl, I'm just going to return AMD 64 every time. Now, that might be kind of your legacy situation, or you may have some containers that only support AMD 64. So that's how you can use the node selector and schedule those on your cluster. And yeah, everything is fine. The same thing can be done for the ARM 64 architecture. So I have an equivalent file, which is pretty much exactly the same, except for the container now has the ARM 64 tag here at the end. And then the node selector is for ARM 64. Okay, so if I take that one, and then let's do an apply -f with ARM 64. The way it goes. And then let's go back and get the pods. Okay, so now I have another one running. So I've got one of each, right? Because I also had one replica there. So yeah, the node selector can be used to take architecture-specific containers, put them on the right nodes, and then you can use your cluster that way. Now, eventually over time, which you may want to get to, is the multi-architecture deployment. So in that case, we're going to do this one. So what I've done here is I changed the image to be the GoArch X. So that's the image that I built with BuildX. It supports both architectures. Had that tag of 1.0. And that's pretty much it. So in this case, what we have is 6 replicas here. And if we apply this one, it's going to schedule 6 replicas with some mix of AMD 64 and ARM 64, and the right nodes will pick up the right container images, and then it will just run. So let's apply this one. It'll be created, and then let's do get pods here. Oops. Okay, so now what we have is the 6 nodes running that I started, and then those 2 older ones. So you see one AMD, 1 ARM, and then 6 multi-arch. Okay, so now I have a script here, this check, which is basically going to go hit the endpoint kind of in a loop, and then let's see what happens. So if we hit that, you'll see you'll get some ARM 64. It looks like we're getting lots of ARM 64 there. And you'll see then some AMD 64s mix in. So as you go through, it'll schedule, it'll go to whichever nodes will react or respond to that, and you'll see the architecture is printed. And you'll see some of these are coming from the ARM deployment. Some of them come from the multi-arch deployment. I didn't see the AMD. Oh, here's one up here, AMD 64, their deployment. Okay, so that gives you a pretty good feel for how to work with the multi-architecture cluster. We have 2 different node groups. In the end, if we have containers that can run on either one, they can just run identically, and they can be used on either architecture. Right. So by doing this, really what you can do is maybe make a migration that's over time, where you start off with your AMD 64 containers. You can add in an ARM container, see how that works. Use the node selector to schedule those, and then over time, if you want to phase out some of the AMD 64s for that price performance benefit, can certainly do that. But it gives you a way to kind of ramp up without an all or nothing, and just try pieces of whatever your bigger solution is. Okay, so I think that pretty much covers it. We went over the image creation, how to build it, mixed architecture cluster, 2 different node groups, and how we can schedule either the individual architecture containers or the multi-arch on the cluster. Okay, so maybe we'll wrap it up there. We can take any questions if we have them.
Amazing. We have a lot of questions. It's going to be a good discussion, I think. Yeah. For one question, just to lay foundations, like you said, has price, performance, and sustainability. It seems so amazing. Like, are there any drawbacks that we should be aware of?
Yeah. So in terms of drawbacks, I mean, it takes a little work. Okay. So,
Yeah.
I mean, in order to get the price performance advantage and sustainability, you kind of have to do something. I mean, in a lot of cases, let's say new hardware comes and it's faster and it's cheaper, and you can take your exact same software and just move it onto the new hardware. No work. I save money, goes faster. That's ideal. In this case, it's not quite that easy because we have to deal with a new architecture sometimes. So yeah, there's a little bit of a minus in that you might have to, build your containers for multi-architecture. It'll probably complicate your CI/CD a little bit as you ramp this up. But hopefully the initial investment you make to get onto the ARM architecture is going to be worth it in terms of the price, performance, and sustainability.
Cool. And then for people who are total noobs like me and they want to play with this, you said that there are ways, but what's like a super easy way for a total noob to set up a multi-architecture, at least an ARM architecture situation to play?
Yeah, it depends kind of what you have access to, I guess, I mean, there's lots of ARM development boards. I mean, even if you're using a Mac with Apple Silicon, you can even use Docker Desktop, which has now built-in Kubernetes feature. And if you do that, you'll basically have a one-node Kubernetes solution on your laptop that's ARM64. Right, so you don't have to do anything special. There's other ARM development boards that you can use and install, various Kubernetes distributions and so on and use. Cloud is probably the easiest. I mean, all the major cloud service providers now have ARM. The one I probably would highlight if you're super new is Oracle Cloud. So they have a free tier, which gives you access to ARM servers. These are from Ampere, so it's an ARM server, and basically you get 4 virtual processors, and I think it's 24 gig RAM, always free. So you can just start up even more than one VM. You could have a dual core VM, 2 of those with plenty of memory, and you could build your own cluster very easily. So yeah, just check all your cloud service providers have ARM instances now.
Super cool. So I'm going to get to audience questions. We have a question from Alexander. Alexander had a lot of great questions. What workloads are okay for ARM architecture? Could it be Java, native, or others?
Yeah, all of those. Yeah, so there's no real limitations in terms of workloads. Yeah, and all of those things should definitely work. It can be, they can be interpreted languages, can be Java, can be compiled things, C, C++, Go, Rust. Yeah, all the popular languages work.
Excellent. And then we have, this one is more for me, I think. It's oops. I lost the one that's for me. But what kinds of workloads would be best to fit to deploy in these multi-arch deployments? Could we see inconsistent results from each type? That's a great question.
You definitely can. I mean, it depends a lot. The workloads depend a lot on the underlying hardware, and there's different instance types. So when ARM architecture kind of first came into the cloud, AWS was really the pioneer. They've been deploying ARM instances since 2018, basically, and so they're on the 3rd generation of Graviton now, and it depends on your workloads of better fit. So these kind of workloads, that price, the price is better web serving or others that are really kind of scale out, and they're not performance intensive in terms of floating point or other things, because they're able to respond very quickly with lots of traffic, and that was really where your best benefit was obtained, I would say, in most cases. But over time, performance keeps getting better and better. So even if you have more computational intensive workloads, and you get into like the C7G family from AWS, those are going to have very good performance as well. So again, it's really just kind of finding the instances that have the right hardware for your workload, and depending what it is, you'll get a good result.
Excellent. And this is the one that was for me, and it's a compliment to you. Being able to see it in real time makes so much sense, which I totally agree with. Will there be a recording to watch this later? I'm unfamiliar with the LinkedIn side, but I know that this is also streaming on YouTube. CNCF has a YouTube channel. So if you go there, go to the live tab, you'll be able to see a recording of this. Thank you. And then let's go for what other ARM-based architectures are possible?
Okay, so the question isn't totally clear in that the ARM architecture has many versions. Okay, so we're on actually version 9 at the moment. Okay. And it started 33 years ago. So that's kind of a wide time span. But for the most part, what you're going to find in cloud service providers and generally, all other hardware, you'll find a recent version of the architecture where everything is 64-bit. And they're based on typically like the ARM Neoverse N1 processor or the V1 processor. So these are kind of server class processors that are running. Now there's lots of other ARM things that are targeted more for edge computing or embedded, or if anybody knows Raspberry Pi, that's kind of one of the early versions of the ARM version 8 architecture that's still out there. Tons of people use Raspberry Pis. There's 32-bit versions of the architecture that go back in time. So yeah, there's a lot of derivatives over time, but what you'll find now in kind of server and cloud is like new 64-bit architecture with high core count and good performance.
Excellent. So I just want to make a quick note that it sounds like the demo that you showed today, if people want to get their own hands dirty with it, they're able to do that on GitHub with this URL. And I put it up during the stream too. So play with it. It looks amazing. We have a question from Kyle. How well does this integrate with parallel processing?
Yeah, I'm not totally sure about that. I mean, I don't think there's anything different about architecture that is anything different in terms of parallel processing. So, most applications, you can write applications with multiple threads running on multiple cores and so on. You can build a cluster with lots of nodes. Yeah, I wouldn't say there's anything special about what we're doing here today that's any different than whatever you do with parallel processing today.
Excellent. We have questions rolling in as fast as we can answer them. I really enjoy all of this conversation. So thank you. Great. Yeah. What if developers prefer keeping ARM-based physical box on the desk? What are the options if you want one in your hands?
Yeah, that's a good question. So there's a variety of things. I mentioned, you could have laptops with the ARM architecture, so that's available now. In fact, there's there's a Windows laptops. There's even Windows Dev Kit, which came out, but probably I'm thinking that's not super interesting to people here. So Linux is a possibility. There's a bunch of boards and different kind of things. I don't know, maybe I have one. I don't know if you can see the camera.
Oh, fun.
Okay, here's one, which is a Kadas. I can see that one. Kadas Edge 2.
Oh, nice.
Yeah.
Cool.
Yeah, so this is an 8-core, ARM, I think it's Cortex A76, with pretty good sized memory. You can get a large memory in there, and you can run Linux and do that. So yeah, that's definitely a possibility. So I think if you start looking around, you'll see lots of different ARM hardware. You probably just didn't notice it or pay attention before.
Cool. I have a question. So you went through how to make a multi-architecture container image. Is there any reason you wouldn't want to make your container image work in a multi-architecture way?
No, I don't think so. I mean, I would definitely recommend it because it gives you more options, right? Then you can try different type of hardware, add different nodes to your clusters, see the performance you're getting, look at the price, and make those decisions. But the only reason you wouldn't is if you had some software that couldn't run on the ARM architecture. Maybe you have I don't know, dependency of some kind or some container that you can't control or change. I mean, the one place I have run into some troubles is a lot of applications have layers of containers, and some of them you don't know where they came from. If I can't trace them back to the origin in order to build it for ARM. That does happen sometimes, but not a lot.
And that's actually kind of related to Kunal's question, which is, did jars need to be compiled to be architecture specific?
No, Java itself, is independent, but sometimes you can do native code in Java, right? So you can mix Java with native code, and there's a JNI is an interface to call that native code. So that's where you could run into a problem. You could think I just have a Java application, but really you got some native code embedded in there you might not have known about.
And then how do you end up finding out? Just by the error messages?
It'll fail. Yeah, it'll fail for sure. Yeah.
Let me get back to the questions. What is LSE, Large System Extension?
Okay, so yeah, large system extension was an enhancement to the ARM architecture somewhere in version 8 that makes it more efficient for handling atomics, right? So the original, as ARM grew up, the number of cores, like in your phone, say example, those are all ARM cores, and
Mm-hmm.
most people probably have 8 cores in their phone. And when you're doing, atomic instructions and locking and so on, um, the way that it worked was fine for 8 cores, but then somebody built a server with 64 cores and then 128 cores, and now I don't know what the largest ARM server, 192 cores maybe. And the atomic instructions weren't great, so they were improved in the architecture. And so when you compile your application, these things are built into your libraries, typically, like your underlying libraries in Linux or whatever your runtime is. And if those are updated to use these better atomics, you can get a much faster performance. So when ARM was newer, you'd see a developer move over to ARM, they would run their application, they say, oh, it's slower than I expected, right? And
Yeah.
that could have been the cause, was either their libraries weren't updated or their compiler wasn't updated, and they ended up with some kind of older atomics, which had slower performance.
I'm not quite sure this question, but maybe you can help me figure out. Docker images can have multiple tags, like version and architecture.
Mm-hmm.
So I guess I don't understand the question. 2 different tags simultaneously? Does that make sense to you?
A little bit. I don't know. Is my screen still sharing or no?
It's not, but oh, no, it's not. I don't have a way to turn it on.
Okay.
But if
Yeah,
you
that's
share
fine.
it, I can. Okay.
That's fine. I mean, yeah, in Docker, you have the ability to use tags
Mm-hmm.
to specify whatever you want it to mean. I mean, some people
Mm-hmm.
might put the version as their tag, like, version 1, version 2, or Golang 1.18,
Mm-hmm.
where the 1.18 could be the tag. Or you can put the architecture there. I mean, that's pretty much totally up to you as a container creator, how you use the tags.
Mm-hmm.
Now, regardless of what you do, if you look, like in Docker Hub, I showed that pull down, it will record the architecture that the images are for, kind of independently of the tag. So yeah, a lot of people use the tags just to kind of denote architecture, but it doesn't have to be. It's totally flexible.
Cool. And what are the long-term plans against ARM64 cloud and on-prem?
Oh, long-term plans.
Or maybe
Yeah, I don't
short-term
know.
plans too. Do you know of any future plans for ARM?
Oh, sure. Yeah, there's lots of stuff happening all the time. In fact, cloud service providers are constantly announcing, new hardware. Um, there was some events recently. So Google Cloud Next was a few weeks ago, and they announced new ARM instances. So they had, originally some instances already in Google Cloud, and now they announced some new instance types with, better, faster hardware, better price performance. I mean, the message is pretty much the same. The hardware gets
Yeah.
better and the price performance improves. And yeah, there's always new instances going in for the cloud service providers, and new servers being built as well. I mean, if you just look at server hardware, you can buy off-the-shelf servers with ARM architecture. Yeah, they constantly get better, faster, cheaper.
Nice. I don't know what the HPC acronym, but can multi-ARM work with HPC applications? What's HPC, please?
Yeah, HPC is high performance computing.
Okay.
So yes, definitely HPC works with ARM. And in fact, for a couple of years, I don't think it's true anymore, but the Fugaku supercomputer, which has won the performance crown for the biggest or fastest supercomputer, was based on the ARM architecture. So it's definitely used in HPC applications. Yeah, everything works the same. You just need to build your software for the ARM architecture, build containers, kind of just how I showed. Yeah, and HPC software is typically like very large scale applications. So like your weather forecasting application or something that requires big hardware and large software. Yeah.
Excellent. What vendors produce production-ready Java, JRE, and JDK for ARM64?
Oh, that's a good one. Yeah, there's a variety. I mean, you can use OpenJDK. It's perfectly fine. I use that a lot. The other one, which is pretty good, is Corretto, it's called, from AWS. So they have a Java distribution. And because they're definitely interested in getting people onto the Graviton processors, which are based on ARM, they provide that as well. So that gives you an easy distribution. So again, that one is easy access. It's open source. So I would say OpenJDK and the AWS Corretto are probably the most common.
Excellent. And then, so I have one more question for you. So those of you watching, if you do have any more questions, now's your chance to get those in. But right now we have one question, which is, what are the best practices when preparing for ARM64 cloud deployment? And are there any anti-patterns? What are those?
Yeah, so what I would definitely say your best way forward is to start small and incremental. Okay.
Yeah.
And like I said at the beginning, if you can just get a VM going and then start experimenting, just in a manual sense of, how you build your software and how you create your containers, because you're going to easily spot when things go wrong if you do that. The pitfall is kind of like, okay, everything looks like it works. Like my CI/CD system is good, and my cluster has ARM nodes, and so you just like push the giant go button and expect the whole thing to just magically work. That's probably a bad idea, because you'll be digging in log files and wondering why all sorts of stuff is failing, and you'll probably spend a lot of time at it. There's actually lots of stories, if you just search the web, about companies that have migrated to ARM64, and they give talks regularly at industry conferences. And that's usually what they say is like, okay, I started small with one VM. I started making inventory, trying stuff out, made a few tweaks here and there. And, it took me a few weeks or whatever to work through my entire application. But once it was up and going and I look back, I didn't really change much, just a few minor things here and there, and have good results.
That's wise. And then the second part of the question was, are you aware of any anti-patterns?
No, not really. It's just basic software development stuff here we're talking about.
Yeah.
Change one thing at a time and make forward progress.
Absolutely. So no more questions came in, so that means it's about time to say goodbye. Is there anything you'd like to say in closing before I say the closing script?
I know, just thank everybody for coming. Yeah, definitely give the ARM architecture a look. I just want to point out one more reference. If you want to learn more, we have a website which is called learn.arm.com. Learn.arm.com. It's very easy. It's a place where you can learn.
Learn.arm.com. Excellent.
That's right.
Thank
so
you.
If you go there, you'll see lots more materials. And yeah, thanks again.
Yeah, thanks for a great presentation. Thank you so much for sharing your time and your expertise with us, Jason. Thanks, everyone, also for joining today's episode of Cloud Native Live. It's great. Jason was great. Learning about multi-architecture clouds is amazing. And also learning how to build multi-architecture images was super cool. So I loved, as always, the questions and the interaction from the audience. Y'all are the best. And here at Cloud Native Live, we bring you the latest Cloud Native code, usually on Tuesdays and Wednesdays. There wasn't one yesterday, but we'll have one again next week. And it'll be at noon US Eastern at the same time. And thank you so much again for joining us today. Thanks to those who watched the recording, and we'll see you again soon.